Good morning, geometry. This video is for chapter 12, day 2. We're looking at chords. When are they congruent and what are the arcs that are formed by the chords? So remember from vocab day 1, a chord has endpoints on the circle. So that's a chord right there, AB. AB is a chord, so is CD on that same picture. Okay, a couple of ways that chords can be congruent. Okay, when they are congruent, their corresponding arcs are congruent. So if the chords are congruent, so are the arcs. If the arcs are congruent, so are the chords. So what that means is if AB and CD, if these are equal, okay, if AB is equal to CD, that means that the arc AB and the arc CD are the same. That means that arc AB is congruent to arc CD. They have the same amount of degrees. Okay, if they're the same length, they cut off the same amount of degrees. Okay, another thing that's true, they're only congruent if they are equidistant from the center. So if we want same thing, AB to equal CD, then what has to be true is the distance from AB to the center E. Okay, EF has to be the same as EG. These two pieces have to be exactly the same. Okay, so that's EF and EG. They have to be equal. Okay. If a diameter or radius is perpendicular to a chord, okay, 90 degrees, so like the green ones that I have right there, okay, then it's going to cut the chord in half, okay, bisect the chord, and it's going to bisect the arc. So it's going to cut the red piece in half, and right here we're going to cut this blue arc in half in terms of there's going to be the same amount of degrees on either side. So if there's 20 degrees right here, there's going to also be 20 degrees right there. Okay? So that's what's explained on these blanks. So if these, so EH is one of the radii of the circle if it's perpendicular to AB, okay, which is the red one on the top, then that means that the green or the red line is getting cut into two equal pieces, AF and FB, and the arcs are getting cut in half. So the measure of the arc from A to H is the same as the measure of the arc from H to B. Okay, hang on one sec. I'm going to fix one thing on my smartboard. All right, so what we have next is just a bunch of examples talking about the same ideas that are above. So that's what we're going to look at. So these different examples. What we're going to see is a lot of times we're going to see that we have some chords. They're going to be marked as congruent. So like these ones are, they're marked as congruent. That means that the arcs that are cut off by those have to be congruent. So this 115 arc has to be equal to the 7x plus 24 arc. So I know I could write 7x plus 24 has to equal 115. Okay, we're going to solve this for x by subtracting 24 from each side. We're at 7x is equal to 91. Then we're going to divide both sides by 7. So x for this one has to be 13. Okay, second one is going to be very similar, going the other direction. So what we have marked as congruent are the arcs this time. If the arcs are congruent, okay, that means that the chords that cut off those arcs need to be congruent. So I know that JK has to equal LM. I know that JK has to equal LM, and JK is 52, and LM is 18x minus 2. Okay, solve for x. Add 2 to both sides. We have 54 equal to 18 times x. Divide both sides by 18, and we get that x has to equal 3. Okay, you can always plug your x's back in and make sure that your answers are making sense. Okay, numbers 3 and 4. This one is going to be similar again, just like the second one, where we have the arcs marked as congruent. So that arc has to be congruent to this arc. They gave us that. That means that these chords have to be congruent. VW has to be congruent to XY. So these have to be congruent as well. So I know VW has to equal XY. Okay, be careful with what the directions just said. It says find XY. So we'll get there in a second. VW is 9x minus 34. That's equal to 4x plus 1. That's what XY is equal to. Okay, we're going to move the x terms to the left, so subtract 4x from both sides, we get 5x. Okay, add 34 to both sides, we get 5x equals 35. That tells us that x is 7, okay, which is not our answer because they want us to find xy. So that means xy, so this is an important part of our answer, but not our answer. Xy is 4 times 7 plus 1, okay, because xy was the one that was 4x plus 1. We're taking the 7 and plugging it back in, okay, which is 28 plus 1, which is 29. So xy is 29, okay. Number 4, same idea, find the measure of arc RS, so I'm going to figure out how many degrees that arc is. That arc has to be equal to this arc because these two chords are marked as congruent. So since those are congruent, the arcs have to be congruent. So I'm able to set those arcs equal to each other. 11x minus 72 is equal to 5x plus 6. Okay, we're going to solve for x and then plug it back in to get the measure of arc RS. Subtracting a 5x from both sides, you get 6x. Adding 72 to both sides, we get 78. Okay, dividing 78 by 6, we get that x equals 13. Okay, and then we're going to take that 13 and we're going to plug it back in right there because RS is the one that's 11x minus 72. So the measure of arc RS is equal to 11 times 13 minus 72. Okay. If you do 11 times 13 and then subtract 72, you get 71 degrees. You should be able to check that answer by plugging x into the other one. Okay, 5 times 13 plus 6 should also be 71. Okay, let's look at numbers 5 and 6. For number 5, the directions say, again, to just find x. Okay, but this one's a little bit tricky. So here's my congruent arcs. Okay, this is my congruent chords, sorry, which means that these right here are my congruent arcs. This arc has to be congruent to this arc. So if the bottom one is 6x minus 20, I know I have another 6x minus 20 right here. Okay, so one way you could do this is by adding those 3 arcs up and getting a total of 360. So we're going to do a 6x minus 20 plus another 6x minus 20 plus a 76. That's kind of this arc right here. Okay, and we're going to set all of that equal to 360. Okay, and we're going to solve from there. So what that gives us, okay, is we have the two 6x's add to be a 12x, okay, and then I have a negative 20, another negative 20, and a positive 76, okay. Those are going to add to a positive 36, and that's going to be equal to 360, okay. I need to subtract 36 from both sides. If you do that, you end up with 12x equal to 324. Okay, and if you divide by 12, you get that x has to equal 27. So remember, half of a circle is 180 degrees, and an entire circle is 360 degrees. Okay. Number 6 says if MP, so MP is right here, that's the distance from the chord to the center, is 5x minus 34, and PN is 2x minus 4, find MP. So what we know that these arcs are congruent, okay, because they gave us that. What that tells us is that these chords are congruent, okay? So this piece has to equal this piece. What that means, from what we said at the beginning, okay, then this distance from the center has to be the same. So this piece has to equal this piece, the red and the other red MP has to equal PN. Okay, so 5x minus 34 has to equal 2x minus 4. And then we solve. So we get 3x by subtracting the 2x to the left. We get 30 by doing negative 4 plus 34. And then we get x equals 10. Okay, that's not what they asked for. So we're going to plug that back into MP, which was 5 times 10 minus 34, which is 50 minus 34. So MP is 16. Okay, that's the first page. Let's move on to the last page. Okay, number 7, if DE equals 11x plus 15 and FG equals 32x minus 27, find DE. So this one, they're looking for something different. Okay, they gave us that these are the same. Okay, if those distances from the center are equal, that means the chords have to be equal. So DE and FG, they have to be equal this time. They have to be congruent chords since the distances from the center are marked as congruent, those perpendicular distances. So I know that 11x plus 15 has to equal 32x minus 27. Okay, I'm going to move the 27 over by adding it with the 15, so that's 42 on this side. I'm going to subtract 11x from both sides, and that's going to give me 21x on this side. Divide both sides by 21. 2 is equal to x. Okay, they want us to plug that into DE. So 11 times 2 plus 15, which is 37. So our final answer is 37. Okay, number 8, find the measure of MP, the arc MP. So this is what we're eventually going to get right here. Okay. We are going to use 360 again for something like this. Okay. Once we find what we need here, okay, once we're able to get that amount of degrees, then we'll be able to plug that x in and figure out our answer. So this one's just going to take a couple of steps. So the first thing we can figure out is we know that these arcs have to be congruent. Okay, these arcs have to be congruent because the distances at the center are the same again. So I know that this arc has to be the same as this arc because these two things are marked as congruent on the picture. So if that's true, then the first thing I can do is go 9x minus 43 equals 5x plus 33. And those arcs have to be the same. So I can set those equal to each other, solve for x, plug it back in, and then I'll use 360 at the end to get the red arc, which is what they want. Okay, this is going to be a 4x if I subtract 5x to the left. 33 plus 43 on the right, that's 76. Dividing by 4, I know that x is 19, okay, which is a helpful number because then it helps me figure out these blue arcs. Okay, so if I plug 19 in, okay, so I'm going to find the measure of, let's say, MN. Okay, this arc, if I find this one first, okay, that's 9 times 19 minus 43. Okay, 9 times 19 minus 43, that comes out to 128. So I know that this is 128, and I know that this is 128. Okay, so together, okay, these two arcs are going to add to 256. So together, those two make 256, okay, all the way around here. Okay, so then to get the red arc, okay, which is what I want, okay, the measure of arc MP, okay, well, that's just 360 minus 256. Okay, so that's going to equal 104. This one has to be 104. Okay, so that one had a couple of extra steps, but we got that final arc by using 360 degrees. Next, number 9, it says in circle Z, if RS equals 18 and TY equals 42, find each measure. So they gave us that RS equals 18. Okay, what I know from that, if that's 18, then there's a couple of 9s in here. So that RS is getting cut into two pieces. RW would be like a 9, and then this would be like a 9. Okay. We also know that TY, okay, this piece right here is 42. Okay. I know that that piece right there is a 42. So that means that I'm going to have another 42 right here. All right, so let's find what they're asking for, and then solve for whatever they need. So TV, okay, that's this piece right here. Well, I know that these two arcs have to be congruent because they're both equidistant from the center. So this has to also be 18. TU has to be 18, but that means that there's a couple 9s again. So the distance between T and V, that's V right here, is 9. Okay, the distance between T and U is going to be 18. Okay, 9 plus another 9. Okay, WS, okay, W, but the distance between W and S, okay, I already have as marked. Okay, maybe it's hard to see, but that's this piece right here, okay, which is once again half of 18, so 9. Okay, YU, I already have marked. Okay, that's this piece. This piece has to be congruent to this piece. If this is 42, this is also 42. So this is 42 degrees. Okay, and then RS, the entire arc over here, well, these arcs have to be congruent. So if this entire arc is 42 plus 42, that's 84. That means this has to be 84. Okay, very similar problem for number 10. They're going to give us some pieces and then have us kind of either double those or cut those in half. So BG is 17. That's going to help us find BC. So if this piece is 17, this is 17 more. So this is 17 times 2. So this is 34. Okay. FB. Okay. These are the arcs that would be congruent, but FB is just going to be a piece. Okay. FB is just a piece. So this is going to be 17. Okay. AB, the arc. Okay. The arc AB is from here to here. Okay. What I know is CHA. Okay. That's going the other way around. Okay. We know that that is 256 degrees. Okay. What that tells us, okay, is that these two have to make what makes 360 with that, so 104. So each one of these arcs has to be 52. This would be 52, and this would be 52-1. So 52 degrees for AB and for BC. Okay, and then the measure of arc EC. Okay, EC is just this little piece right in here. Okay. I kind of covered over the E with my 52, but this is going to be half of 52, so that's 26. Okay, hopefully those make sense. Those pictures came in a little bit small, so hopefully you're able to work with those. 11, okay, number 11, we're looking at QM. QM is right here between Q and M. Okay, that's 6x minus 11. Okay, and MR is right here. Okay, those pieces are congruent pieces of congruent arcs. Okay, the entire arcs are congruent because, again, we have them marked as equidistant from the center. So we're going to take those two pieces. We're going to set those equal. 6x minus 11 equals 2x plus 9. Okay, so subtracting 2x to the left, we get 4x. Adding 11 to the right, 9 plus 11 is 20. Dividing 4, x equals 5. Okay, they want us to take that and plug it in for mn. Okay, well, that's a little bit tricky. Okay, mn is this entire piece. Okay, but that's just mr times 2. Okay, so we have mr, which is right here. We have 2 times 5 plus 9. Okay, so that piece gives us 19. but then times 2, that's where our 38 comes in. So 38 for our final answer. Okay, number 12. Okay, if this arc CI is 7x minus 15, okay, and EF, okay, equals 12x minus 18, they're going to ask us to find arc CI. Okay, so what I need, okay, is something that I can set this blue arc equal to. Okay, I need to get the measure of the blue arc eventually. Okay, what I know is that this arc will equal the green arc, and the red arc is just 2 times CI. So 2 times 7x minus 15. If I double that one, that's going to be equal to the green one, okay, which is 12x minus 8. So I have to double that one, the blue one, to get the red one. Okay? So make sure you distribute right here for your algebra. We have 14x minus 30 equal to 12x minus 8. If I subtract 12x from both sides, I get a 2x on the left, and add 30 to the other side. Negative 8 plus 30 is positive 22. Divide by 2. That tells me that x is 11. Okay, I want to plug that in. 11, not 1. Okay, that tells me I want to get that plugged into CI, the measure of CI. Okay, now that I know what x is, 7 times 11 minus 15. Okay, that comes out to 77 minus 15. Okay, so 77 minus 15, okay, which is 62. All right, last little piece here, okay? Use the circle on the left here for questions 13 and 14. So to find VW, all right? So finding VW, what's going on right here? VW is this. Sorry, let me fix my board one more time here. There we go. So I'm going to try to find VW. So that's this distance right here. Okay. Well, that's just being cut in half by this line right here. Okay. So this line right here is cutting that VW in half. So if I can figure out what this piece is, then I can double it. And what I have right there is a right triangle. I have a right triangle right here, okay, where 13 is the hypotenuse. So if I want to find VW, the first thing I want to find is ZW. So I'm going to call this like B, okay? I have 5 squared plus B squared equals 13 squared. So Pythagorean theorem. So that's going to be 25 plus B squared equals 169. Subtract 25 from both sides. B squared equals 144. So B is the square root of that. So B is 12. Okay? If B is 12, okay, that means that this piece is now 12. Okay, right here is 12, which means this is 12, which means VW is 24. Okay, I want to find in number 14 the arc, the amount of degrees that arc YW is. So YW is this arc right here. Okay, remember that what we need is whatever that central angle is, that's what this arc is going to be. So again, let me erase a little bit so you don't see more than you need. So this arc will match whatever this angle is. Remember, central angles. Central angles are going to be congruent to the arcs that they intersect. So can I figure out this angle in the center, okay, with this right triangle? So what I could do, let me just redraw this. Okay, what I have is this is my right angle. Okay, this is 13. Oops, yeah, that's 13. Sorry. This is our 5. Okay, and we know that this side is 12, but I'm just going to leave it like that for now. Okay, what I want to do is find that angle. Okay, if I can find that angle, that's right here in the picture. That's going to equal this arc out here. So what I do is SOHCAHTOA. So this x right here, this is the hypotenuse. This 5 is adjacent to the angle that I'm looking for. So I have A and H, which tells me to use cosine. So the cosine of that angle, the ratio, cosine ratio of that angle is going to be adjacent over hypotenuse, 5 over 13. Okay, what that tells me, okay, is I can get the inverse cosine. Okay, x is equal to the inverse cosine of 5 over 13. Okay, and that's calculator work. Make sure that you are in degree mode, not radians. 67.4 is what comes out of that. Okay, if it's 67.4 here in the middle, it's 67.4 here on the outside. So that's going to be the measure of the arc that I need. So the measure of arc YW equals 67.4 degrees. Okay, 15 and 16, okay, are going to be exactly the same thing. So I'm actually going to stop this video at this point. Okay, thank you for watching. Let me know, or your teacher know, with whatever questions you need. We are on worksheet number 2.